For this video, I've done some research into the topic of reflection and especially the way Java implements reflection. And reflection is a term that I've heard used before and vaguely knew the definition of, but that I'd never used in school or had used in any personal projects. So, what is reflection? This is the definition that I found on stackoverflow.com. Reflection is a language's ability to inspect and dynamically call classes, methods, attributes, etc. at runtime. So that kind of makes sense when you think about the word reflection. When you look at a mirror, you reflect, and you're looking at yourself and you can modify your behavior. And it's the same thing in the programming language. A programming language that implements reflection can examine its own code or other code and dynamically call or modify it. So let's see reflection in action. I've created a small example program called Reflect Test to experiment with, and let us see some of the uses of reflection. Let me introduce you to the program. So you can see that we have one package in the program called main. And inside main we have two source files. One is called Reflect Test and one is Name Generator. Take a look at Name Generator first. So you can see here that Name Generator has a small database of first names and a small database of last names. And the important part is it has a method called getName, which returns a string. All it does is take a random name from the first name database and a random name from the last name database, join them together and insert a space in between them. So it's a pretty simple program. Reflect Test only has one method, the main method that will be called when the program is run. And what this main method does is prints out however many lines were specified of random names, which are given by the name generator's getName method. See whether it compiles. Clean compile. So let's see. It compiled successfully, and we should be able to run it. Alright, so running with the default, without any argument specified, it prints out 10 names. We can also specify a 5 and it'll print out 5 random names generated from the getName method. So that's a pretty simple program. Now that you understand basically how it works, let's see how we can fit reflection into it. I revamped this class to do the same thing except use reflection instead of simply calling the method. So this is the new version of Reflect Test. And there are two variables that are important that didn't exist in the last version. One is this gen class, and the type of gen class is the class of Java. So this is a variable actually representing a class in Java. And then the getName method, it's a method class. So this method class actually holds a reference to a method inside a class, which is something I hadn't ever seen before. So the program starts the same way. It gets the arguments off of the command line and sets gen class to whatever the user specified as the second argument. If the user didn't specify an argument, or if it can't find the class, then gen class defaults to the name generator class that we've already seen. So after the class has been found, then we need to instantiate this method, or this variable, the getName. And all it does is take gen class, the class that we just found, and search for a method called getName. And finally, once the method has been found, we have sort of a pointer to the functionality of a method that we can then call invoke on. So in this for loop here, doing the same thing, iterating num names times, it sets a string equal to whatever this method returns, getName.invoke. And so as you can imagine, calling invoke on a method object invokes that method and returns an object, which we then cast to a string called name. This should work exactly the same way. We'll compile that. Compiles well. So we should be able to run it. We'll tell it to just run with its default parameters and print 10 names. So it still works. And the difference between this program and the last program is that if you recall in the last program, we called the getName method on a name generator class. But in this newer version using reflection, as you can see, we never actually call a method getName. Instead, we find that method, store it as a variable, and then call the method invoke on it. So why is it any better to use reflection? Why is it better to call invoke on the method object rather than simply calling the method? And the answer is it isn't always better. Reflection isn't something for everyday use, it's for special circumstances. Let's imagine that we've done a really good job with reflect_test and name generator, and now we want to market them. But here's the catch. We want the clients to be able to write their own name generators that work in whatever way they want. And we want our program to be able to use those classes written by the client. But we don't want to release our source code, just the class file. So basically, we want our program to work with code that it has never seen or touched before. Is that possible? It is, because of the way we've used reflection. Let's take a look. So let's pretend now that we're a client that has just purchased reflect_test, and we want to use it to create cool usernames that we can distribute to our own clients. We'll show an example now of how that could be done. So inside our source folder, we still only have that one class, or that one package main. But now we'll create another package that we will call cool username, spelled correctly. Inside cool username, we'll create a new Java file which will contain our custom name generator that will generate usernames. I've already written this class, so we'll just copy it in. So this works pretty much the same way as name generator does. It has a database of adjectives, a database of subjects, and this is the important part. It has a getName method, just like name generator does. If you remember, that's what reflect_test is going to be looking for. To call is a method called getName. And in this username generator class, it just appends an adjective to a subject and adds a random number to the end of it. So let's compile this and create the class file. There we go, it compiles. But note that username generator doesn't know who is going to be calling it. And in fact, there's no main method here, and no piece of code ever even references username generator. reflect_test doesn't know anything about username generator. Username generator doesn't know anything about reflect_test. But because of the way we've used reflection, we'll be able to tell reflect_test where username generator is, and it will be able to use it. We can run reflect_test now, and we'll tell it to print out 20 names. And here's a key part where we pass the path to the class that we're providing that will generate the names, and that is in cool username dot username generator. So you can see that it found the class successfully and it used it. It's generated 20 cool usernames that we can now dispense to our clients. So the interesting thing about this, and the cool thing about this, is that the user decides at runtime what class he's going to pass to the program for it to use. The program basically says, I don't care what you give me, or who created it, where it is, or how it works, as long as it has a getName method that returns a string. And we added that functionality without ever even having to recompile reflect test. So that's a powerful feature. And that about wraps up what I know about reflection. Reflection may not be the answer for most programming problems, but used in the right situations, it can provide powerful, customizable functionality to your program.